Based on our discussions, one thing is clear, right? Price and demand goes in opposite directions. This is called the law of demand, which can be stated as follows. When the price of a good goes up, people buy less of it, other things being equal. When the price of a good goes down, people buy more of it, other things being equal. As a definition, we can say the law of demand states that if a consumer's demand for a good moves in the same direction as the consumer's income, the consumer's demand for that good must be inversely related to the price of the good. Ceteris paribus. Just to explain this qualification here means it has to be a normal good and not an inferior good. Two concepts we'll see a bit later. And ceteris paribus, it basically means other things held equal. Ceteris means other things and paribus means equal. The ceteris paribus is what gives power to this law. This relation between the consumer's optimal choice of the quantity of a good and its price is very important and can be quantified. This relation is called the demand function. If the prices of other goods, the consumer's income and taste and preferences etc. remain unchanged, the amount of a good that the consumer optimally chooses becomes entirely dependent on its price. Thus, the consumer's demand function for a good gives the amount of good that the consumer chooses at different levels of its price when other things remain unchanged. Ceteris paribus. The consumer's demand for a good as a function of its price can be written as Q equals dP, where Q denotes the quantity and P denotes the price of the good, which means Q is a function of P, right? Let's take a real life story. Title of the story, A Mistaken Price Change Confirms the Law of Demand. In Wisconsin Rapids, Wisconsin, employees at a Citgo station intending to change the posted price of petrol from $3.43 per gallon to $3.49 per gallon accidentally changed the price to $0.349 per gallon. A station attendant said that within minutes, people are coming so fast everything was super crowded, like an amusement park. During the few minutes between the error and correction of the mistake, customers used self-serve pumps to buy hundreds of gallons of petrol, filling up their vehicles and any cans they had readily available. Thus, a significant, albeit mistaken, decrease in the price of petrol induced a substantial increase in the quantity of petrol demanded. What do you think would have happened if the gas station's pricing error had shifted the decimal point in the opposite direction, yielding a posted price of $34.9 per gallon? Let's take another case study now, this time at a more aggregate level. How much more petrol would people buy if its prices were lower? We have explained that the quantity of petrol demanded falls as the price rises. We are now ready to study empirical evidence that backs this up. Brazil and Venezuela share a border and they have similar levels of income per person. Both are also large oil producers. Each produced about 3 million barrels per day in 2030. However, they have radically different energy policies. Like most countries, Brazil heavily taxes the sale of petrol. In contrast, Venezuela aggressively subsidizes the sale of petrol. To compare their policies, when Brazilian drivers paid $5.58 per gallon in 2013, the Venezuelan drivers paid only $0.04 per gallon. The law of demand predicts that this lower price should be associated with the higher quantity demanded, all else held equal, right? And what does real world data tell us? In fact, per person petrol consumption is almost 5 times higher in Venezuela than in Brazil. This graph plots the price of petrol on the vertical axis, including taxes and subsidies, and the quantity of petrol demanded on the horizontal axis. As you can see, there is a negative relationship between price and quantity demanded. Let's also add Mexico to this figure to give you a sense of how another Latin American country with similar per person income compares. Mexico provides a small subsidy on petrol and consequently falls between the other two countries. The law of demand predicts a negative relationship between price and quantity demanded, and the real world data confirms that prediction. So yeah, the law of demand works in the real world too, even though it was all built on all the assumptions about rationality etc. that we used in constructing a utility analysis in the last chapter. Let us get back to the demand curve now. Take my demand curve for iced tea again. The quantity demanded tends to fall as price rises, right? This actually happens due to these two reasons or effects, the income effect and the substitution effect. First is the substitution effect, which occurs because a good becomes relatively more expensive when its price rises. When the price of good A rises, I will generally substitute good B, C, D, etc. for it. For example, as the price of fish rises, I might eat more chicken. In this case, if the price of iced tea rises, I might start looking for a juice shop nearby. A higher price generally also reduces quantity demanded through the income effect. This comes into play because when prices go up, I find myself somewhat poorer than what I was before. My purchasing capacity has come down. If iced tea prices double, I have in effect less real income which can be used for purchasing goods. So I will naturally curb my consumption of goods in general and hence iced tea as well. Let's see this in a graph. And for this, we need the ICs again along with the budget lines. The income and substitution effects of a change in prices occur simultaneously when someone makes a choice. To see why this is the case, consider that Crusoe's income is M, that is budget line, and let the prices of the two goods be P1 and P2. Suppose in this situation, the optimum bundle for Crusoe is X1 star, X2 star, which we can plot like this. Now consider a fall in the price of good 1 by the amount delta P1. The new price of good 1 is P1 minus delta P1, right? Overall, the budget line has shifted. Let's plot the new intercepts and draw the new budget line. This shift here is as a result of the price change. The price change actually has two effects which is captured inside this shift. One, good 1 becomes relatively cheaper than good 2 as compared to what it was before. 2. The purchasing power of the consumer increases. The price change in general allows Crusoe to buy more goods with the same amount of money as before. In particular, he can buy the bundle he was buying before by spending less than the original M. Both these effects of the price change, 1. The change in the purchasing power, and 2. The change in the relative price, influence the consumer's final optimal choice bundle. And let's explore that now. But before we do that, a quick rewind to what we studied earlier. Remember how intercepts changed in two cases we studied earlier? One when Crusoe's income increased, and 2 when price of a good changed. If Crusoe gets more income, he can buy more goods at the same price. So we saw that both the intercepts change and the budget line shifts outwards. If price of a good changes, we saw how price of milk came down, and this meant a new intercept on that axis, right? So in this case, the budget line swiveled outwards. Remember these two movements. A parallel shift is due to income change and such swivels are due to relative price changes. Consider this. To buy the original bundle, originally M had to be spent. But now, how much has to be spent? Less than M, right? See, at the prices P1 minus delta P1 and P2, the bundle X1 star X2 star now costs P1 minus delta P1 X1 star plus P2 X2 star, which equals P1 X1 star plus P2 X2 star minus delta P1 X1 star, which equals M minus delta P1 X1 star. The original bundle thus costs a bit less due to the drop in prices. By how much? Delta P1 X1 star. So delta P1 X1 star is the additional income here due to the fall in price. We know that the increase in price reduced QD or quantity demanded. But to isolate how much of that change was due to income effect and how much due to substitution effect, we do some graph wizardry now. What we will do is we'll adjust the purchasing power of the consumer or the budget line back to the initial level, just to remove this effect and see what happens. How do we do this adjustment? By taking away the extra income. So the consumer's income is reduced by the amount delta P1 X1 star after the fall in the price of good 1, so that his purchasing power would be adjusted back to the initial level. This is done by shifting the new budget line back parallelly by delta P1 X1 star. Now the situation is like this. At the new prices P1 minus delta P1 and P2 and the adjusted income of M minus delta P1 X1 star, the consumer's new optimum bundle is X1 star star X2 star star. Here x1 star star must be greater than or equal to x1 star. Why? Remember monotonicity? Let's put some numbers to this because all this x star star is getting complicated, right? Consider for example a consumer whose income is rupees 30. Suppose the price of good 1 is rupees 4 and that of good 2 is rupees 5. And at these prices, the consumer's optimum bundle is 5,2. Now suppose price of good 1 falls to rupees 3. That is a price change of 1. After this fall in price, if the consumer's income is adjusted as in the algebra we saw earlier and reduced by rupees 5, which is 5 into 1 to 25, she would be in a position to just buy the new bundle 5,2. Now note two things here. One, note that the change in the price of good 1, which is rupees 1, times the amount of good 1 that she was buying prior to the price change, which is 5 units, is equal to the adjustment required in her income, which is rupees 5, which is nothing but delta P1 into x1 star. Note that after adjustment, the consumer will be in a position to just buy the older bundle again. Let's come back to the graphs now. Once we add this adjusted line to it, now we have a finished diagram. The green line in the diagram represents the original budget line of the consumer when her income is M, and the prices of the two goods are P1 and P2. All points on or below the budget line are available to the consumer. As the consumer's preferences are monotonic in nature, the optimum bundle x1 star x2 star lies on the budget line. The yellow line represents the budget line after the fall in the price of good 1. If the consumer's income is reduced by an amount of delta P1 x1 star after that, there would be a parallel leftward shift of the yellow budget line and we get the red budget line. Note that the shifted budget line also passes through x1 star, x2 star. Remember, this is because the income is adjusted in such a way that the consumer has just enough money to buy the bundle x1 star, x2 star again. Now in this diagram, we can decompose the price effect into its two components. First, the change in the optimal quantity of a good when its price changes and the consumer's income is adjusted so that she can just buy the bundle that she was buying before the price change is called the substitution effect. So all we have done here is we have removed the increased income impact by adjusting for it to isolate the substitution effect. 2. However, the income of the consumer does not in fact reduce due to the fall in the price of good 1, right? The consumer would experience a rise in the purchasing power. And what is left in the original movement after removing substitution effect is due to this income effect. The change in the optimal quantity of a good when the purchasing power changes consequent upon a change in the price of the good is called the income effect. Thus, the two effects of a fall in the price of good 1 work together and there is a rise in the consumer's demand for good 1. In our diagram, these two effects can be seen like this. From here to here is due to substitution effect and the rest is due to income effect. And the total is the price effect. How to remember this? Remember how we were pivoting the budget line earlier? Pivoting the budget constraint indicates substitution effect and shifting it indicates income effect. So this part to the swivel is the substitution effect and this part to the parallel line is the income effect. Microeconomists use a construction called the Slutsky equation to consider the relative magnitudes of these two effects, which allows them to say a little more about the merits in terms of utility of the two goods. Let's recap once again. When a price changes, it causes two effects on the consumer. A substitution effect, which emerges when the budget line pivots, which shows how much of the change in consumption of one good changes relative to the other good. And an income effect, which emerges when the budget line gets shifted parallelly to take into account a change in the total amount of money a consumer possesses. We can put the two effects together using the Slutsky equation. Put simply, the Slutsky equation says the same thing as our graph, that the total change in demand is composed of an income and a substitution effect, and that the two effects together must equal the total change in demand. Delta x1 is equal to delta x1s plus delta x1n, where delta x1s is the substitution effect and delta x1n is the income effect. This equation is useful for describing how changes in demand are indicative of different types of goods. Now, the thing is, the substitution effect must always turn out to be negative. So, the substitution effect is always in the direction opposite to price change. If price increases, demand decreases related to other goods and vice versa. But the income effect may be positive or negative, depending on how consumption of a good changes with income. How does consumption change with income? The demand function we know is a relation between the consumer's demand for a good and its price when other things are held constant. What if instead of studying the relation between demand for a good and its price, we study the relation between the consumer's demand for good and the income of the consumer? The quantity of a good that the consumer demands can increase or decrease with the rise in income depending on the nature of the good. For most goods, the quantity that a consumer chooses increases as the consumer's income increases and decreases as the consumer's income decreases. Such goods are called normal goods. In the Slutsky equation, a normal good has a positive income effect. And so, as the income goes up, demand goes up, and as income goes down, so does demand. Thus, a consumer's demand for a normal good moves in the same direction as the income of the consumer. But not all goods are normal. Some are inferior in an economic sense. There are some goods for which the demands actually move in the opposite direction of the income of the consumer. Such goods are called inferior goods. We don't mean that they are of poor quality, but that they have a negative income effect. So, for instance, as income goes up, a person consumes less of them. Instant noodles, for example, aren't generally held to be a product that people consume unless they are constrained in terms of money. As you get richer, you consume less of them. In this case, the substitution effect is negative, but the income effect is also negative. Crusoe used to eat a lot of instant noodles when he was in college, but once he landed a job, his demand shifted to better food. Same for most of us. As long as we are in college or school, we eat a lot of junk food, street food, Maggi, etc. Actually, because they're cheaper. Then we graduate to pizzas in college, maybe because of higher allowances, and then to slightly better food post-job and to proper food after marriage. As the income of the consumer increases, the demand for an inferior good falls. And as the income decreases, the demand for an inferior good rises. Other examples of inferior goods include low quality food items like coarse cereals. One thing to note here is that a good can be a normal good for the consumer at some levels of income and an inferior good for her at other levels of income. At very low levels of income, a consumer's demand for low quality cereals can increase with income. But beyond a level, any increase in income of the consumer is likely to reduce her consumption of such food items. Summarizing, income effect is positive in case of normal goods and negative in case of inferior goods. This is kind of strange, but note one more thing. Inferior goods do not violate the law of demand. They change with income, not with price. However, there are some exceptions even to the great law of demand too. First is a category called Veblen goods, originally postulated by one of the funniest economists, Thorstein Veblen. He was a social critic in addition to being an economist, and he liked to poke fun at inequality and the rich people. He said that rich people indulge in irrational behavior quite often. For instance, when price of diamonds and some luxury cars increased, the demand actually increases. Reason? They are perceived as articles of distinction. These goods are bought not with the purpose of consumption, but for the purpose of showing off. So if price is higher, the show of value only rises. Hence B in CBA rises along with C and maybe even more. And so demand increases. Veblen called this sort of consumption conspicuous consumption. To define it, a Veblen good is a good for which demand increases as price increases because of its exclusive nature and appeal as a status symbol. A Veblen good has an upward sloping demand curve, which runs counter to the typical downward sloping demand curves. Second, violating law of demand is done by another category of goods called Giffen goods. In the case of inferior goods, what happens? The rise in the purchasing power or the income of the consumer can sometimes induce the consumer to reduce the consumption of a good. In such cases, the substitution effect and the income effect work in opposite directions. The demand for such a good can be inversely or positively related to its price depending on the relative strengths of these two opposing effects. If the substitution effect is stronger than the income effect, the demand for the good and the price of the good would still be inversely related. However, if the income effect is stronger than the substitution effect, the demand for the good would be positively related to its price. Such a good is called a Giffen good. These goods are known as Giffen goods after the economist who first investigated their existence during the Irish potato famine. They are often thought of as curiosities, but they do exist even though as a small subset of the total set of inferior goods. How were they discovered? During the Irish potato famine, as the price of potatoes, their staple food, rose, impoverished consumers had little money left for more nutritious but expensive food items like meat, which is the income effect. So even though they would have preferred to buy more meat and fewer potatoes through the substitution effect, the lack of money led them to buy more potatoes and less meat. Giffen described this phenomenon and hence these goods are named after him. Later, this was studied more scientifically in a 2007 study by Harvard economists Robert Jensen and Nolan Miller. Jensen and Miller conducted a field experiment in Hunan province in China, where rice is a dietary staple. Randomly selected households were given subsidized rice and wheat. The economists found strong evidence of Giffen behavior exhibited by the Hunan households with respect to rice. Lowering the price of rice through the subsidy caused reduced demand by households for rice, while increasing the price by removing the subsidy had the opposite effect, which is directly against the law of demand, right? Look at this quote by Alfred Marshall, one of the founding fathers of modern economics. As Mr. Giffen has pointed out, a rise in the price of bread makes so large a drain on the resources of the poorer laboring families and raises the marginal utility of money to them so much that they are forced to curtail the consumption of meat and the more expensive foods. And bread being still the cheapest food which they can get and will take, they consume more and not less of it. Let us have the definition now. A Giffen good is a good for which demand increases as the price increases and falls as the price decreases. A Giffen good also has an upward sloping demand curve, which is contrary to the fundamental law of demand, which states that quantity demanded for a product falls as the price increases, resulting in a downward slope for the demand curve. A Giffen good is typically an inferior product that does not have easily available substitutes, as a result of which the income effect dominates the substitution effect. Let us look at a few other types of economic goods as well. Economic goods, free goods, and economic bads. In economics, we call any scarce good, that is, where demand is more than supply, which has value and for which people are willing to pay money to acquire, as economic goods. A non-economic good or a free good is something which is not scarce, hence supply is more than demand. So the prices are zero, i.e. no one would be willing to pay for it. Air is a typical example of this. Even water used to be a good example, but not nowadays, right? An economic bad, on the other hand, is a good that people are actually willing to pay to not acquire or get rid of. Example could be something like pollution or traffic. When we take a high-speed tollway, we are paying to avoid the good called traffic or the economic bad called traffic. So these are the types of goods. Let's list them out and see a summary table now. Take your time and make sure you're clear on all of them.